Okay, so we're going to look here at section 8.2. I'm actually going to do this entire set of notes, and if there's points where you want to pause it and try a few on your own, and then go back and hear my explanation, that's probably a good idea. But as I was looking through this set, I figured I might as well just go ahead and work through the entire set. It's a relatively brief set of notes here. Um, the first property that you see up here at the top, a radical can be written as rational exponents, is actually one of the properties that I used in the previous video for simplifying your radical expressions. So you have b to the m over n. That's the same, that's equal to the nth root of b to the m power. So you might recall in the last video, I actually went more this way in the video that I said, okay, well, b to the m over n. So you can go both ways, okay? So down below in these examples, it wants us to write the rational exponents as a radical and then simplify if we can. All right, so in the first one, it's x to the 1/2 power. It's a little hard to see there. Pretty sure, yeah, that's x to the 1/2. So then really that's the same as the square root of x to the first power, or you could just simply write the square root of x. Remember, if it's the square root, you don't have to write that index number at the top. So if we look on over to our right, the cube root, or 27 raised to the 1/3, that would be the same as the cube root of 27 to the first power. So we think about, okay, well, is there a way that we could simplify this? Can we, is there a number that we can multiply times itself 3 times to get 27? And sure enough, we can, that we could multiply 3 to the 3rd power and get 27. So then we can simplify this. This is the same as 3 to the 3 divided by 3, which is 3 to the 1st power, which is just 3, is our final answer. And like I said before, you can go straight from here to here if you like. I'm just showing you the steps to get there if you need them. All right, if we move on down then to the next row, we've got the cube root of negative 8y to the 9th, or sorry, I keep saying it, negative 8y to the 9th raised to the 1/3 power is the same as the cube root. So this would be the cube root of negative 8y to the 9th. Now, think about here is that you can take an odd root of a negative number, so we can keep working in this problem. We ask ourselves, what can we multiply times itself 3 times to get negative 8? And then hopefully you agree, okay, well, I can do negative 2 to the 3rd power. And since 9 is already a multiple of 3, I just leave it alone. And then as I come out, I just divide. So negative 2 to the 3 divided by 3, that's just going to give me negative 2. Y to the 9 divided by 3 is going to give me y cubed. So negative 2y cubed, final answer. Okay. The next one, you have 16x to the 12th raised to the 1/2 power. So that's the same as the square root of 16x to the 12th raised to the 1st power. So now I just want to go through and take the square root. So the square root of 16 is 4. And then 12 divided by 2, x to the 6th power. Final answer, 4x to the 6th. All right, we'll move on down to the next row. 9 raised to the 5/2. So remember the bottom number is your index, so that's the same as the square root of 9 to the 5th. All right, so inside there, I want to write this 9 to the 5th as multiples of 2. So hopefully you would agree that that's the same. 9 to the 5th is the same as 9 to the 4th times 9, right? Because when you multiply, you add your exponents, so that would be 9 to the 5th still. All right, so now if I take the square root of 9 to the 4th, that would be the same as 9 to the 4 divided by 2. And then the next one, you've got the square root of 9. The square root of 9 is just 3. 9 to the 4 divided by 2 is the same as 9 squared, right? 4 divided by 2 is 2. 9 squared is 81, and 81 times 3 is 243. Final answer. Now I will tell you from the very top, 9 to the 5/2, if you put in your calculator like this, 9 raised to the 5 divided by 2 in parentheses, your calculator would give you 243 straight away. Okay. Example over on the right, a squared b to the 7th raised to the 1/7 power, so that's the same as the 7th root of a squared b to the 7th. I can't write a squared as a multiple of 7, but b to the 7th already is a multiple of 7. So just take out what I can. The 7th root of b to the 7th would just be b, and then I would have left inside the 7th root of a squared. Final answer. Okay. Down below, they say let's write each radical with a rational exponent. So with that first one, you have the square root of 17. Remember that inside underneath the square root, 17 is raised to an imaginary 1 power, and if you don't have a number on your radical there, it's assumed to be a 2. So this really is 17 to the 1/2 power, and that would be your final answer. Moving to the right, the cube root of x squared, I can rewrite that as x to the 2 divided by 3, x to the 2/3. And then lastly, x to the 20th, or the fourth root of the fourth root of 20. So this is, remember, imaginary 1 here, so this is the same as 20 to the 1/4 power. Final answer. Okay. All right, and then if you flip it over, next page, we are just reviewing at the top some properties of exponents. These really should be just that, a review. That when you multiply, you add your exponents. So b to the m times b to the n is b to the m plus n. When you divide, you subtract your exponents. And then the power rule is when you raise a power to a power, you multiply. Looks like that's not coming through well on the video there, so let me put that in. So this is m plus n and m minus n there, and of course that's multiplication on the bottom one. Over on to the right, your distributive property, it just says if you have a quantity in parentheses raised to a power, both pieces in that parenthesis get raised to the power, whether it's all on the top or if you have a division. Okay, everything gets raised to that power. Just below that, the reciprocal property just says that if you have b to the negative m, that's hard to see, that's the same as 1 over b to the positive m, and then anything raised to the 0 power is always 1. So down here below in these examples, they just want us to simplify. So I'll go in numerical order, and numerical order is straight down the columns. So if I go down this first column, 3 to the 1/5 times 3 to the 2/5, you have the same base here. So you can keep that base, and the rule is when you multiply, you add these exponents. So it would be 1/5 plus 2/5, and then that would give me 3 to the 3/5. So that's in rational exponent form. It doesn't tell us here how they want it, so we'll do both forms. And then that could be rewritten as the 5th root of 3 cubed. Which 3 cubed is not hard to figure out, and so we could say, okay, well that's the same as the 5th root of, what, 27? So this is in exponent form, and this is radical form. Okay, we'll move on down to example 2. You have division here with the same base, so the rule is keep that base and subtract those exponents. So 1/4 minus 1/2. That would give me 7 to the negative 1/4. You don't leave negative exponents, so we would write that as 1 over 7 to the positive 1/4, or 1 over the 4th root of 7. So that gives you your exponent in radical form. Okay. Moving on down below in example 3, you've got a power raised to a power. So that rule is then when you raise a power to a power, you multiply. So then that would leave us with 5.2. When you raise a power to a power, you multiply. So these 3's would cancel out, and that would leave you with the 2/4. And 2/4, I'll write it so we can see it step by step. So you have 5.2 raised to the 2/4, which is the same as 5.2 raised to the 1/2. There's your exponent form. To write it in radical form, that would be the square root of 5.2. Okay. Down below that, you have the square root of 242. So you want to think about that that numerical list that I made for you in the last video. For 8.1, you're looking for numbers that will divide evenly, perfect squares that will divide evenly into 242. So remember that list is 4, 9, 16, 25, and so on. Because remember, this is 2 squared, 3 squared, 4 squared, 5 squared, and so on. 242 happens to be the same as 121 times 2, and the square root of 121 is 11. And so that's outside the house, 2 stays inside. Final answer there. And I mean, because this is 5 squared, and then I could have kept going. 9 squared is 81, 10 squared is 100, 11 squared is 121, and so that's how I knew, 242, 121 can go into that. All right, moving on down to example 5. You have the 4th root of 243. Well, let's think about 243 is the same as 3 to the 5th power. All right, so then I need to write this as multiples of 4. So I could write that now as the 4th root of 3 to the 4th times 3. And so now the 4th root of 3 to the 4th would just be 3. And then I would be left with, so I'm taking that one is coming outside. And then this 3 is staying inside. So 3 times the 4th root of 3. Final answer. All right, we'll get another color and we'll move over to that second column there. So come back up. Example 6. Here you're raising a power to a power, so we're going to multiply. So we would have x to the negative 1/6 times y to the, those 2's would cancel out, to the 1/5. So I don't want to leave negative exponents, so I would have y to the 1/5 up top, and I would move x to the 1/6 on the bottom. That would be in exponent form. And then I could rewrite using my radicals. Up top we would have the 5th root of y, on the bottom the 6th root of x. Okay. So I'm giving you both forms so that you're prepared whenever you get into your MyLabs Plus. All right, so in the next one you've got the 5th root of x squared y cubed, and then that's raised to the 15th power. Let's think about this one like so, that just ignoring the 15 on the outside for a moment, that you have here x squared y cubed, and then it's the fifth root, so that's the same as raising it to the 1/5 power, and then it's get raised to the 15th power. So you've got a power to another power. Here's what I would recommend that we do. Let's do these outside powers first here. So when you raise a power to a power, you multiply. So 1/5 times 15 is just going to give you 3. So that's going to give you x squared y cubed, and then that'll be raised to the 3rd power. And now when you raise a power to a power, you multiply. So x to the 6th, y to the 9th. Final answer. Lots of different ways you could have approached that problem. That was just one way that I saw that was a little maybe cleaner. Okay. And solution keynote's a different way, so you've got multiple ways to think about it and look at it. All right, so move on down to example 8. In example 8, you've got this entire piece here that's being raised to a negative power. It's legal to get rid of that negative power by just switching what's inside, switching places. So that means, what I mean by that is that 3yz comes up top and 7x goes on the bottom, and now we're all raised to the positive 6/5. So now from here, I would be raising everything in there to the 6/5 power. Or, let's see the best way I want to think about this one. This would be the same as the 5th root of everything in there, 3yz over 7x, all raised to the 6th power. That's a 6 there. Here we go. All right, so if I do that, then we'll come over here. I've got the 5th root. I would have 3 to the 6th, y to the 6th, z to the 6th. Actually, I just thought of a better way. So let me just erase that last little step there. Let's just erase this. Okay, so I'm pretty sure you're tracking with me here that if it's all raised to the 6/5 power, then that's the same as the 5th root of this, the 5th root of all of that raised to the 6th power. All right, so now from here, I need this to be a multiple of 5. So couldn't I just say that this is the same as the 5th root of 3yz over 7x raised to the 5th power times 3yz over 7x? And that could, because that one is like raised to the 1st power, right? So now, I use a different color here. So now, at that point, this first term is raised to the 5th power, so 5 divided by 5, that'll just come out and become 3yz over 7x times this piece, the 3yz over 7x here, is raised to the 1st power, so it's going to be left inside the radical. So times the 5th root of 3yz over 7x. That would be your final answer. That one was a little tricky. I mean, there's other ways to do that one, but I think, like I was saying on the last one, I think that's the cleaner way. All right, we'll move on down to our next one. We're here taking the square root of everything. So like I've talked about before, the square root, you want to get everything raised to an even power. So that first piece there is x to the 5th. And also, one big square root is the same as two small ones, so I could do it this way. X to the 5th is the same as x to the 4th times x. And then y to the 6th is already even, so just leave it alone. And then on the bottom, I have the square root of z to the 12th. Since that's even, I don't need to worry with it. Now just come through and take the square root of pieces that I can. The square root of x to the 4th, x squared. Square root of y to the 6th, y cubed. And then I'd leave the square root of x up top. And then the square root of z to the 12th would be z to the 6th. Final answer. All right. And then lastly here in example 10, I'm taking the cube root of everything underneath that radical, and everything is already a multiple of 3, so I can just come straight away then. So this would be like saying x to the 6 divided by 3, y to the 9 divided by 3. You don't have to show this work, but I thought I'd show it one more time, to the 15 divided by 3. So you hopefully by now are able to come to, okay, well this is x squared, y cubed, and z to the 5th. Final answer. Okay. All right, let me know if you need anything. Thanks a lot. Bye.